Alright, in 8.2, we're going to be discussing the law of cosines. So the law of cosines is also on the identity sheet down there with the law of sines, down in the bottom right-hand corner of the identities. So the law of cosines is, we're now going to consider any triangle, so we have something that looks like this. Since rigid motions preserve congruent figures, we can always place one side of the triangle on the positive x-axis with a vertex at the origin. So imagine taking this triangle, and we're going to rotate it around to where vertex C is going to be located at the origin, and we could have a picture that looks something like this. And then we are going to use this triangle here to figure out what the law of cosines has to be. So let's go ahead and label what we know. So we know this angle right here, we said is angle capital C. So then that would make this side little c. We have this is going to be angle B, which means this distance is going to be little b, and then that makes this angle A, so that makes this side here little a. Well, we can coordinatize this if this distance is A, since vertex C is at the origin, and this side of the triangle is on the x-axis, that point has to be at A, comma, 0. We don't know where this vertex is, but to help us out, we are going to say we know it's at some point x comma y. We don't know what x and y are, but it's at some point x comma y. All right. If that's the case, we can now drop a perpendicular down to the x-axis here. And if this is at point x comma y, then this point is on the x-axis, has to be at the point x comma 0. This distance from the origin to here has to be x, and this distance would have to be y. But since we dropped a perpendicular, we now have a right triangle here, but we need to calculate this distance. So if we want to find the distance between 2 points, how do we do that? Well, if I want to know how far is the number 4 from the number 7, what would I do? Well, I would subtract 7, take away 4 gives me 3. Well, what if one of those numbers is negative? How far is negative 2 from 7? Well, that would be 7 minus a minus 2, which would give us 9, which is also correct. So the distance from A to X, regardless of whether X is positive or negative, is going to be A minus X. And if that's the case, then we can now apply the Pythagorean theorem to this big right triangle with side lengths A minus X, Y, and C. So then by the Pythagorean theorem, we have that A minus X squared plus Y squared has to equal to C squared, where C is the hypotenuse. Okay. So then we can expand this. So a minus x squared is a minus x times a minus x. So that's a squared minus ax plus x squared. So putting all of that together, we get a squared minus 2ax plus x squared plus y squared is equal to c squared. If we look at this little triangle here, the one in green, we have side x, side y, but that also makes a right triangle if we go from the origin back to vertex A with hypotenuse B. So then by the Pythagorean theorem again, x squared plus y squared equals c squared. So then putting that together, we get a squared minus 2ax plus b squared is equal to c squared. So we can keep simplifying this because x was a symbol that we introduced right here. But if we look at our angle C is measured from the positive x-axis out to here. And on a circle, we can figure out what that is in terms of sines and cosines. So we're talking about the x-coordinate of our triangle that we have here. So talking about x, we're talking about cosine. And cosine is equal to adjacent over hypotenuse for our reference triangle. So if we look up here, we're going to have that the cosine of C is equal to our adjacent. Our adjacent is x, and the hypotenuse of our reference triangle is B. So solving that equation for x gives that x is equal to B times the cosine of C. So we have that x is equal to B times the cosine of angle capital C. And we put that in, and finally we get c squared is equal to, I'm going to rewrite this, a squared plus b squared minus 2ax, but x is b times the cosine of angle C. And this is called the law of cosines. So we'll notice in this incarnation, the law of cosines looks an awful lot like the Pythagorean theorem. In fact, if we get rid of the minus 2ab cosine C, it gives us exactly the Pythagorean theorem. And we'll notice we have negative 2ab times the cosine of C. If C is equal to 90 degrees, that is, if C is a right angle, then the cosine of 90 degrees is 0, so then that would go away and it would give us exactly the Pythagorean theorem. So the law of cosines is a generalization of the Pythagorean theorem. The Pythagorean theorem only works for right triangles, whereas the law of cosines will work on any triangle. So this minus 2ab cosine c is the correction term for the triangle not being a right triangle. So the law of cosines has 3 equivalent forms. So it has the version we just wrote down, c squared equals a squared plus b squared minus 2ab cosine of angle c. And I'm going to put the degree sign on there to indicate that it's an angle. But we can permute these symbols. We can also have a squared is equal to b squared plus c squared minus 2bc times the cosine of a. And we could also have b squared is equal to a squared plus c squared minus 2ac cosine of side b. So in our 3 versions of the law of cosines, that angle is always the same as the side that is isolated. So if it's side C is by itself, then it's the cosine of C. If it's side A that is isolated, and so forth. The law of cosine of A, B, and cosine B. So law of cosines comes in those 3 flavors, and we can pick whichever one will make our life easiest or will work for what we're trying to do. All right. So let's go ahead and take a look at example number 1. So in example number 1, we want to solve the triangle ABC, and we want to round all of our solutions to the nearest tenth again. So as always, let's start by drawing a triangle. We have our A, we have our B, and we have our C. We have side A is 52, we have side C is 48, and we have angle B is 125.2 degrees. So now we have side angle side this time. So side angle side. So this one is going to be SAS for our side angle side. And to solve side angle side, we're going to use the law of cosines. So if we go back to our handout now, all of the examples we've done so far, so A, B, and C, were all side angle side. The 2 sets of examples we're going to do in this next section are going to be law of cosines. So when we run into the situation where we have side angle side, our method to solve is going to be law of cosines. And this is going to be 8.2, example 1. So when we're doing the law of cosines, so we have side angle side, the first thing we need to do is solve for the unknown side across from the known angle. So our unknown side, in this case that we want to solve for us, is angle B. So we're going to use the law of cosines, which is b squared is equal to a squared plus c squared minus 2ac times the cosine of b. So we're using it in its form that we had right here. Since we wanted the unknown side b, we selected this version of the law of cosines. All right, so now we put in our information, and we have b squared is equal to a squared, so 52 squared plus c squared, which is 48 squared, minus 2 times 52 times 48 times the cosine of the angle b, which is 125.2 degrees. So we need to put this into our calculator. So I have 52 squared plus 48 squared minus 2 times 52 times 48 times the cosine of the angle in between them, which is 125.2. Press enter, and I get the number 7,885.55, but that's not our answer. That's b squared, so I actually want to take the square root of that answer, and I get 88.8. Oh, that is not what I wanted. There we go. So this gives us that b is approximately 88.8 in this. So now, second step is we need to solve for one of the missing angles. All right, and I'm going to sketch a picture to help us see why I'm going to put this note. So, note when using the law of sines, avoid the SSA case. So let's take our triangle. I'm just going to grab a copy of it, and then we're going to illustrate what's happening here. So we had each of these, and in the previous we solved for side B, right? And we got that side B was 88.8. So that's over here. We have 88.8 and we have 88.8. So in this case, it doesn't matter if we're trying to solve for angle A or angle C, If we're trying to find angle A, we're going to have a side angle side. And if we're trying to find angle C, we're going to have a side angle side in either case. But when we do the next example, we're going to have to be a little bit careful. Because in this case, we're always going to avoid side-side angle. But we wouldn't want to use, say, this side, so 5288.8, then to try to find, or that using the side angle to try to find a missing side. So if I went side angle and tried to use 88.8, 52, and B to try to solve for angle A, I might introduce the ambiguous case, which I would want to avoid. We don't want to use side angle because remember, that's the case where we can have 0, 1, or 2 triangles. We know that there's only one triangle, so if we use side angle, it may tell us that there are no triangles because the triangle we're trying to make doesn't exist. So we want to avoid that possibility. So for us, let's go ahead and solve for angle A by using one of our things. So in this case, let's just go ahead and use the law of cosines, which will bypass this problem completely. So if I want A, I would have a squared is equal to b squared plus c squared minus 2bc times the cosine of A. And with the law of cosines, we will never have the ambiguous case. So we're trying to find angle A this time, because we don't know angle A, but we do know side A. So this gives us 52 squared is equal to b squared, which is 88.8 squared, plus c squared, which is 48 squared, minus 2 times 88.8 times 48 times the cosine of A. So we start by simplifying, and let's take our 52 squared and minus 88.8 squared minus 48 squared. And that gives us 7485.44 in the negative. So (7485.44), and we got that by going negative 88.8 squared minus 48 squared minus 48 squared minus 88.8 squared. Doing so gives us that number equals negative 2 times 88.8 times 48 times cosine A. And now we're going to divide by negative 2 times 88.8 times 48. And we divide by negative 2 times 88.8 times 48. So we keep our calculation running on our calculator. So we're going to go to pull up our answer. We go second in our negative sign. So the answer from the previous line divided by 2 times 88.8 times 48 gives us this value. But then that's cosine equals this. So we take the inverse cosine of the answer without rounding, and we end up with this. So we ended up with 0.87807 ... equals cosine of A, and then A equals the inverse cosine of this, which is that value right there. So now we have 28.58, so A is about 28.6. And now we can solve for the last angle. And that's going to be 180 minus 28.6, which we just found, minus the angle that was given, which is 125.2. So then we subtract all of those, and we end up with the angle 26.2 degrees. So in this one, we want to set up our law of cosines once again. So we draw our triangle so that we can see what we have. We have our A, we have our B, we have our C, we have side A, we have side B, and we have side C. So we know, so side A is 17, side B is 15.4, and side C is 1.5. So in this case, we actually only know sides, right? So we're going to have side, side, side. So this is our SSS case, which is the very last one on our handout. So when we run into side, 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 we are also going to use the law of cosines. So then it doesn't really matter which side we go to solve for. So we have our law of cosines. So we have c squared is equal to a squared plus b squared minus 2ab times the cosine of c. So that gives us 1.5 squared is equal to 17 squared plus 15.4 squared minus 2 times 17 times 15.4 times the cosine of c. So once again, we need to get cosine by itself. So we minus 17 squared and minus 15.4 squared. We'll grab our calculator. We have 1.5 squared minus 17 squared minus 15.4 squared. Gives us negative 523.91. Negative 523.91 is equal to, and then in front of the cosine we have 2 times 17 times 15.4, and we get 523.6. So negative 523.6 cosine C. So we divide by negative 523.6, and we divide by negative 523.6. So we have negative 523.91 over 523.6, and that should have been negative. And I get this number, 1.000059, which should worry you, because now when I go to take the inverse cosine, I'm going to get a domain error. So I get the cosine of C is equal to 523.91 over 523.6, because a negative divided by a negative is a positive. So then C would be the inverse cosine of this. And this is going to be a domain error. Because as we saw on the previous screen on our calculator, 523.91 divided by 523.6 is bigger than 1, and the domain of inverse sine and inverse cosine is only the numbers between negative 1 and 1. So this is not in the domain. That's not in the domain of cosine inverse, so then no such triangle exists. All right.